Hi everyone. Okay, today what we're going to go through is a complete review of Pythagorean Theorem. And so you'll see that title just put up on the top of the page. And I'm hoping that Pythagorean Theorem comes back to you guys from last year. Not that we're automatic with it. I'm actually going to probably tell you to work with it a little differently this year. But that at least we recognize that term, we've heard it before. What Pythagorean Theorem becomes for us is our first application of how we can use equations to solve problems. So let's take a look at problem A. You've been asked to find the length of the missing side. You see that you have a right triangle, and there are your side lengths of 6, 8, and x. It's important for us to recall, to note, that Pythagorean Theorem is for use in right triangles. Not in triangles, but in right triangles. And therefore, we have to always have a triangle with that 90-degree symbol somewhere in that triangle. And so, if we're able to work our way through, then I want to address Pythagorean Theorem in a high school setting. And so what we're going to go through is how we can use Pythagorean Theorem for the next 4 years. Okay, let's take a look at that first triangle again. And now we're going to jot down our formula for Pythagorean Theorem. Our Pythagorean Theorem states that c squared is equal to a squared plus b squared. Now, on the triangle right now, I'm just going to go through and I'm going to label each of those sides. The only side that has a designated name to it, the only side, is the longest side. And we can always find the longest side by the side that is opposite our 90-degree angle. And we should all be good that that side is called the hypotenuse. The only side in Pythagorean Theorem that has a designation, the only side in a right triangle that has a designation is the hypotenuse. By definition, that is the longest side. And so within Pythagorean Theorem, then x, in this case, the hypotenuse, would be represented by the c. Now, the other two shorter sides don't have a designation. So maybe the 6 is A and the 8 is B, or maybe the 8 is A and the 6 is B. It does not matter as long as our hypotenuse is labeled C. Now, when you take a look at it within Pythagorean Theorem, a couple things should make sense. So I quickly want to go through just the right side of Pythagorean Theorem. So what we see then is we have a side length squared plus a side length squared. Well, the only way that the right side of that equation can equal the left side of that equation is if my value of c is the largest. Like, look at the right side of the equation. It says that if I square something and I add it to the square of something else, then it equals the square of a third thing. Well, the only way that that can be equal, be balanced, is if the left side, that c value, was the larger value. So we need to know then that every time we use Pythagorean Theorem, the side that is all by itself must be the longest side. Okay, now I never need to see Pythagorean Theorem written out. I would suggest, though, for anyone who's unfamiliar with it or doesn't feel like it's automatic to them, then write that down as your first line. It's going to help. Okay, the first line that I would need to see is the substitution of every value into Pythagorean Theorem. So we know that our c is actually called side x on this, so now I have x squared instead of c squared. And then it really doesn't matter what order you put in for your a or your b. So just as I have the diagram labeled, maybe I'll call that 8 squared plus 6 squared. Okay, I need to see the blue. There is your use of Pythagorean Theorem. Now we can simplify some stuff. So some people will be able to simplify that right side pretty quickly because we can say 8 squared is 64, 6 squared is 36. And now we can simplify that to 100. I need to see that blue line of you getting x squared all by itself. Okay, now what do we know? Well, we know then that x is going to equal, and how do we get rid of a squared? Well, we take a square root. Square root of 100 is 10. Now, here's the second part that I want to make sure we come back and address. That I'm hoping there's a bunch of people that say, hey, wait a second, when I take the square root of a number, when I choose to take the square root of a number, I get a plus or a minus within my equation. And I just want you to think back to grade 8 a little bit, because we'll notice that we never wrote that down in grade 8. And even in high school, we will not write down plus or minus, because there's a certain thing that we need to address. Let's look at the positive case. Is it possible that x could equal 10 on that triangle? And I would hope that we'd say, yeah, like x equaling 10 is a reasonable answer. X is our longest side. The fact it's 10, sure. Is it possible that x equals negative 10? And I'm hoping pretty quickly that we can recognize that we can't have a negative length. And so why then do we not have to include the plus or the minus? It's because when we do use Pythagorean theorem, we are always solving for a length. And since we are always solving for a length, we do not have to include the plus or the minus. So you are okay to jump straight to a length of 10. Okay, your solution to Pythagorean theorem, I would need to see the blue lines. You don't have to show me the green, but anyone who wants to show me the green, because they feel like they're going to be a little more on track and avoid risk for mistake, then feel free to include it. There we go. There's us using Pythagorean theorem. So let's jump into B then and see maybe a different way from how we would have tackled this last year. Okay, first thing we notice, we have a right triangle, and we have a relationship that relates the sides of a right triangle, Pythagorean theorem. So c squared is equal to a squared plus b squared. Okay, now I take a look and I recognize that my hypotenuse is always my longest side, and my longest side is opposite my 90 degrees. So my longest side on this triangle has a length of 9. That goes in place of c. Now it doesn't matter the other two. Most people are going to like to put the variable in for the first one, and you'll see why in a second. So I'm going to call side D my side A. That makes my side B 7. Okay, now we can go through and we can calculate. A lot of people are really going to want to put down this line where we calculate everything we can. Now what we'll notice is we have an equation, and this is an equation that we solved last week. For you to get the d squared all by itself, that means that we have to get rid of our plus 49. And so to get rid of that plus 49, then we need to minus 49. And so if we go through, and we subtract our 49, then that gives us 32. Okay, we don't quite have the d all by itself. Now we need to go through and get rid of the squared. To get rid of a squared, I take a square root. Because we're finding the length of a triangle using Pythagorean theorem, I don't have to include the plus or minus. We just all recognize, though, that in this instance, we can't calculate root 32. So what we have to do is we have to round it off to an approximate. And if we are going to find an approximate, if you recall, we're going to put a little dot on top of that equal sign to show that we're rounding. And if we're going to find a side length and there's no rounding instructions, then we're going to round that off to 2 decimal places. And there we go. So we get approximately 5.66 units. Now, this would have been an instance where we would have solved this maybe a little bit differently last year, and you would have been required to remember two different versions of Pythagorean theorem. That's just because we didn't really have solving equations at our benefit. Well, now that we have that at our disposal, now we can just use the exact same version of Pythagorean theorem every time, and we can allow our equation skills to solve for whatever we need. Okay, there is an example of both cases that will pop up for us. What I want to do for the rest of that front side is just look at a couple of occasions that can pop up and some things that can help us a little bit. So let's take a look at question C. So let's take a look at this triangle. We see that it's a right triangle, and we know that we have a relationship between the sides of a right triangle called Pythagorean theorem. So what is Pythagorean theorem? Technically, what is Pythagorean theorem? It's not c squared equals a squared plus b squared. That's just a generic formula. What it really says is the longest side squared has to be equal to the sum of the squares of the other two sides, of the shorter sides. So the more that we can start to look at that relationship, not as c squared equals a squared, like by reading the variables, but instead noting that that is the longest side squared is equal to the sum of the squares of the other two sides. Well, now what we can do is we can start to apply it. So we know that our hypotenuse is our longest side, and the longest side is always opposite the right angle. So we start to get some numbers that are a little bit bigger. Maybe we call A, Y, and B 8. But notice I don't even care anymore about which side is A, which side is B, because I just know that what that means is the sum of the squares of the other two sides. Okay. Now we're going to go through and we're going to calculate some stuff. So let's calculate some stuff. So we need to simplify what 17 squared is, and we're good that that is a 289. And we're good, yikes. And we're good on our 8 squared, there's a 64. Okay, let's get our y squared all by itself. And so to do that, I have to get rid of a plus 64, which means I'm going to minus 64, and there is 225. Okay, how do I get rid of a squared? I have to take a square root. And so when I calculate, the square root of 225, something interesting should pop up, that we should get 15. Now, this problem C should have just been an indicator of, are we comfortable using Pythagorean theorem to find a missing side? But now that we did that, I want us to note that 8, 15, and 17 will form the sides of a right triangle. What that's referred to is as a Pythagorean triple. That those three values all fit within Pythagorean theorem. Well, we have a few other Pythagorean triples. Probably the most famous one, and I don't know if famous is the right word, but the most well-known one or used one is 3, 4, 5. That if you know some Pythagorean triples and you have those in your back pocket, feel free to use those anytime. So I'm going to do a little check. Notice that 3, 4, 5 is a Pythagorean triple because the longest or largest value squared is equal to the sum of the squares of the two smaller values. We do a little check. That left side says 5 squared, that's 25. My right side says 3 squared plus 4 squared, that's also equal to 25. Notice that 3, 4, 5 would fit in Pythagorean triple and make it true. So we have a bunch of Pythagorean triples that we can use. And if you've got a decent memory and you want to hold on to those are ones that you can use at any time. Okay, let's jump into problem D. Okay, why did I want to spend your time discussing D? Well, the first thing I want you to notice, what type of triangle do we have? And yes, we can all say that it's a right triangle because we see the right angle. But I would hope that we could also see that because this side was marked equal to this side, we actually have a right isosceles triangle, because I have a right triangle that has two and only two equal sides. Okay, so why am I spending your time talking about this? Well, we can work our way through pretty quickly on an isosceles right triangle. Okay, we know that c squared is equal to a squared plus b squared. In this case, we can see that our hypotenuse has to be the opposite side. Well, I just want us to take a look at that and say, well, duh, of course the a has to be the hypotenuse. How can a triangle, a right triangle, have two longest sides? It can't. It can't have two hypotenuses. And so in this instance, then, we would get an a squared is going to equal 6 squared plus 6 squared. Well, pretty quickly then, we get a squared is going to equal 36 plus 36. A squared equals 72. To get rid of a squared, I take a square root, and now we have to calculate the square root of 72. Notice the question does not give you any rounding rules, and so if we don't have any rounding rules, then we need to make sure that we round to 2 decimal places. We're going to round, so we mark it as our approximate, and we should come in on 8.49 units. So if the question had been labeled in centimeters, then we have 8.49 centimeters. And there we go. So hopefully not too bad. Make sure that we're good when we take a peek at a right isosceles, and we just notice that whatever sides are equal must by definition be the shorter sides. Okay, let's turn over to the other side of the page now and get a little bit more work with those Pythagorean triples. Okay, so let's take a look at what the problem asks. It asks us a question. No instruction, just asks us a question. Is the triangle with the given side lengths right? So for me to go through and examine that, what I need to do is I need to see, could those 3 side lengths work within Pythagorean theorem? So could I take those 3 side lengths and get a case where I could get the left side to equal the right side, and therefore they would balance Pythagorean theorem? Okay, now we take a look at those 3 side lengths, and the first thing that should jump out to you is 6 is my longest side. And so if this could happen to be a right triangle, if it was a right triangle, then the 6 would have to be the hypotenuse. So let's give it a check. We're going to examine the left side, which is my hypotenuse then. I can sub in my 6. That means by default then, my other 2 sides have to be my 2 shorter sides. That would be the sum of the squares of the 2 shorter values, smaller values. Okay, I'm going to do a quick check on both sides. I'm going to calculate my 6 squared. There's a 36. I'm going to calculate my 3 squared plus my 4 squared. I get 25. And as soon as I see that my left side does not equal my right side, then I know that it did not meet my Pythagorean theorem relationship. And therefore, I can say, to the question, is the triangle with the given side lengths right? No, it is not. Okay, I want you to pause the video and I want you to go through and do a check on the side lengths given in B. Okay, pause the video now. Okay, we're back. So, if we are going to check to see if it's right, then that means it must satisfy Pythagorean theorem. When I scan across, I noticed 13 was my largest value, so that would have to be my hypotenuse. That means my right side is the sum of the two smaller values. Okay, I calculate my 13 squared, that's 169. I calculate my right side, so 5 squared plus 12 squared gives me, and as soon as I see that my left side equals my right side, then I can then state, yes, it is. And what you just learned was another Pythagorean triple. That we noticed that if I have side lengths 5, 12, and 13, then that would form a right triangle. There we go. Okay, so being able to check just to satisfy yes or no on a right triangle is a super useful practice, super useful tool. Okay, let's take a look at our last problem for today. I've given you a little bit of an application question. So at some point you're going to pause this video and you're going to give that problem a read. As we go through and we read this problem, I want us to try to draw a diagram to satisfy the problem. Okay, so what I want you to do is I want you to pause the video in a moment, read the problem, and then try to draw a picture that would satisfy this situation. Okay, pause it now. Okay, we're back. So we start to read this problem and it tells you an RCMP patrol boat left Long Beach, British Columbia and sailed west for 2 hours. It then gives you information that says it sailed west, it sailed north, it then tells you it sailed east. So we need to be able to know which direction is east, north, and south. So the biggest part is I'm hoping most people know that up would be considered your north. When looking at a map, up is considered north. And now, how do we decipher between east and west? Well, I think for most part, if we know our map of Canada, a lot of people tend to use the wording on the map of Canada to help out. When people say that they go out east, then they're referring to going out to like Nova Scotia. And where is Nova Scotia on the map of Canada? It is to the right. There's our east. Okay, if we then start to talk about going out west, and people go, oh, I flew out west, or I went skiing out west, or anything like the mountains out west, then what we're talking about is going out towards BC. So west is then left. Nobody ever goofs up on south. I don't even have to put south on our diagram. Okay, so that should give us a little confirmation if we had a little bit of a hiccup. So, can we make sure then we're going to take another crack at drawing that diagram? Okay, pause the video now. Okay, we're back. So, if we are out at BC, then maybe this is my starting point. The problem tells me that I'm going to sail west, then I'm going to sail north, then I'm going to sail east. Now, that's the direction that I'm going to sail, or that boat is going to sail. I just don't know how long any of those arrows should be when I draw my diagram. But that's my direction. Okay, what we're going to do is we're going to amend, or we're going to change that diagram. We're going to fix it up a little bit. So we noticed that that red arrow was us sailing west for 2 hours at 15 kilometers per hour. Well, if I've been told that we are going to travel for 2 hours and we are going at 15 kilometers per hour, then that's going to give me a total of 30 kilometers of distance. Okay, so I know that that red arrow then is going to represent 30 kilometers. That might have been a bit of a snag for us, and us being able to figure out what the actual length of those side lengths were. So, if that helps you out, then I want you to pause the video and try to finish off the problem. Okay, we're back. Okay, so now I'm going to take a look at my blue. It tells me that I go north for 2 hours at 20 kilometers per hour. That means I'm going north for 40 kilometers. And now the fact that my green arrow tells me I go east for 1 hour at 10 kilometers, I think I can change the length of that arrow. Because I know that the length of that is only 10 kilometers. And relative my red arrow at the bottom, it's got to be much shorter. Okay, the question that I've been asked to solve, and so the one that I need to make sure that I am good to address, how far was the patrol boat from Long Beach? So Long Beach was my starting point. And so what I need to figure out then is, what is that length? So if we are going to go through to solve for that, then maybe I just put a variable in there and I might default to x. Okay, now that we have the diagram, I want you to be able to solve for it. So if we didn't have that corrected diagram, then make the correction, and now I want you to pause the video and finish off the problem. Go to it. Okay, we're back. So for us to be able to now solve for that, well, I have kind of a weird looking shape on here. I have a trapezoid, but I don't really know how to find the side length of a trapezoid. However, I'm hoping that if we thought we could drop a height in there, then we would actually make a right triangle. I know the side lengths of that right triangle. My vertical side has to be 40 because that's the same length as my blue arrow. My bottom side would have to be the entire length of 30, take off 10. That's what gives me that remaining side. So if I take my 30 and I subtract my 10, then my bottom side would have to be 20. So for me to solve this problem, I need to find the hypotenuse on a right triangle with the shorter sides of 40 and 20. So I know I can use my Pythagorean theorem. I know that I'm looking for my hypotenuse. The sum of the squares of the two shorter sides are that. And so now everything else is just me calculating and simplifying. So 40 squared is going to give me 1,600. 20 squared is going to give me 400. And when I calculate that and simplify, I'm going to find out that the length of x squared is 2,000. Okay, I know how to get rid of that squared. That means I'm going to take a square root, and I'm going to have to calculate the square root of 2,000. Now, when I calculate that square root of 2,000, this is where my eyes have to go back to what was a rounding rule. Notice in this question, it gives me a rounding rule, and it tells me that I have to round to the nearest tenth of a kilometer. So I need to round this to 1 decimal place. And so I'm going to get 44.7. Two things of communication. We just rounded that, so we have to put a dot on our equal sign to show that we rounded. And in this problem, there are units on here. So we need to make sure that we include those units. There's our kilometers, and we are good. Okay, I'm hoping that this second part, or this part of today's lesson, was just a straight review of your old stuff, and that you guys can spend a little bit of practice today getting back and comfortable with solving using Pythagorean theorem. Okay, it might have been a little new the way we did it, but it's just equation work for us now. Okay, your job now, jump in and get some practice. Good luck.